Good day everyone. In this video, I'm going to present to you how I solved this machine problem. First, let me explain to you these sets of code. In this machine problem, I am going to use composite quadrature midpoint and trapezoid rules. For composite midpoint rules, let us refer to the formula here. The first line of the code is for function m where inputs are defined. F is for the function of x to be integrated. A and B is for the interval boundaries, and K is for the number of subintervals. In the composite rule, length of subinterval H is equal to the quantity B minus A over K. We initialize S to 0. This is the summation part of the composite midpoint rule. This loop is for the calculation of the summation, that is for the counter I to count from A to B minus H incremented by H. Summation is now equal to the initialized S or the previous value of S to be function of I added by H over 2. As we can see, it is somewhat similar to the summation in the book, but in the code it is simplified, so we do not have to solve for the x's such as the x sub j minus 1 or the x sub j. The loop ends at b minus h in accordance with the simplified formula used. After the loop ends, m or the approximated integral of the function is now equal to h multiplied by the summation s. The second set of the code is for composite trapezoid rule. Let us again refer to the formula used here. The first line of the code is for the inputs, and H is equated again to quantity B minus A over K. Then we have another summation here, initialized to 0. Now, as we can see here in the summation, aside from the first and last term, the summation begins at x sub 1 and not at x sub 0. It also ends with k minus 1. So our counter starts at a plus h and ends at b minus h, incremented by the subinterval length h. The summation is now the previous value of s plus the value of f of I. T is now h multiplied by quantity 1/2 f of A plus the summation we got plus 1/2 f of B. Now let's try this problem. Evaluate this function exactly and show that the result is pi over 4. Then find the approximate value of the integral using the trapezoidal rule with n is equal to 4 subdivisions. Use the result to approximate the value of pi. First, let's input the function trapezoid. Then the function to be integrated. Then the interval boundaries, and k is equal to 4 or the n. Then let's click enter. We have a value of 0.728. So let's try to approximate the pi by multiplying the answer by 4. Answer times 4. As we can see, we have a value near pi. Let's try again this problem using midpoint quadrature rule. First, let's input again the given mid. We have another value 0.7867, and let's try to approximate pi by multiplying this again with 4. And we have a value near pi. Both methods give adequate approximation, but the accuracy is still not reliable.